Hello, so we need to be able to factorise various expressions including quadratics and completing this difference of two squares. Okay, so we need to factorise these expressions. So we have x cubed minus 2x squared, so we need to factor a term that's common to all the terms. So x is common, so x I can pull out to get x squared. No, x squared even, x squared of x minus 2, okay? And that's it. I can't do anything more. Part B, we have x cubed, take away 25x. I could factor an x out to get x of x squared minus 25. And this is the difference of two squares. So then I could say x of then x minus 5, x plus 5, right? And there we are. Part C, we have x cubed, add 3x squared minus 10x. So I can factor an x out as x is common, so x of x squared plus 3x squared minus 10. And then I can perhaps factorise the quadratic inside. So consider we have x squared, add 3x squared minus 10. I need two numbers that multiply to get minus 10 at the end here, and add to get plus 3. Okay, so then I can consider the factors of 10. So 10 and 1, they do not add or take away to get me 3 in any way. Okay, then 5 and 2. Yes, if I do 5 take away 2, I get 3. So to account for the negative 10, which numbers will multiply to get negative 10 and add to get 3 from these two? What negatives do I need to attach on? Well, let's do negative 2, because then 5 take away 2 is 3. 5 times minus 2 is minus 10. And there we are. That factorises x plus 5, x minus 2. Then I can factorise this even further to get x plus 5, x minus 2. And there we are. Cool. Okay. So now we can factorise this. So we need to factorise 6x cubed add 7x squared minus 5x completely. Well, firstly, an x is common. I can pull that out to get x of 6x squared add 7x minus 5. And so to factorise quadratics in this way, where obviously we have 6x squared, a number in front of the x squared. Again, if we were to factorise this quadratic, we need to find two numbers that times to get not minus 5 now, but 6 times minus 5 to get minus 30 to account for that 6 we have, and then add to get 7. And so if we do that, then well, the factors of 30 and 1, these two numbers don't add or take away to get me 7. What about 15 and 2? Nope. What about 10 and 3? Yes, because then if I do 10 take away 3, I'll get 7. Now, to account for the negative, which number here do we make negative? Well, it should be minus 3, because then 10 take away 3 is 7. And times them to get minus 30. So that tells me how I can split up the 7x. Because I know these two numbers add up to get 7. So I could do 6x squared, add 10x, take away 3x. As then that gives me 7x overall, which is what I've got, and then minus 5. Then I factorise the first two terms and the last two terms, and then I go from there. And it doesn't matter what order I do it in. It could be minus 3x first, and then 10x, but it doesn't matter. But then I can factorise. So what can I pull out of these first two terms here? Well, I can pull out a 2x. So then 2x of 3x add 5. Then I can pull a minus out of 3x at 5. Well, what do you know? 3x plus 5 is a common factor in both expressions. I can pull that out to get 3x plus 5 and then 2x minus 1. And so then I factorise that quadratic. Then I can factorise this expression to get x of 3x add 5, 2x minus 1. And there we are. That's completely factorised.